Good morning to all. Today we will continue with the Booth's algorithm. In the last class, we elaborately discussed the Booth's algorithm. So, you can see the last slide here in the Booth's algorithm. Okay. So, we multiplied 13 with minus 6 and we got the results here. Okay. So, basic idea of the Booth's algorithm, as I said in the last class, that is 0 0 or 1 1, then no operation, and then 0 1. So, that means this block of 1 is going to start. So, then it should be subtracted and then 0 1. So, that means block of 1 is just finished. So, in that case we have to add. So, that is we have to add it. So, that is we said in the last class, right. So, now this is one example. Here we got the results, that is no doubt, but problem here if you see that how many partial products. So, this is partial product 1, this is partial product 2, this is partial product 3, this is partial product 4, this is partial product 5. So, that number of partial product will be the same as the number of bits in the multiplier. Okay. Now, if we increase the number of bit multiplier, so complexity also will increase and number of bits also will increase. Okay. And number of partial product increase means then we need many half adder. Okay. So, now question is how can you reduce or how can we make much faster multiplication algorithm. Okay. So, first there are two approach for doing so. First one is using that is something called bit pair recoding, another is CSA. So, we will focus on first part, that is something called bit pair recoding of multiplier. Okay. So, we will use the Booth's algorithm. So, therefore, Booth's algorithm as we learn it, if it is 0 0 then or 0 1 1. So, no operation, okay. No addition or subtraction, no operation means only shift. Similarly, if it is 0 1, that means block of 1 is going to start. So, we did it A equal to A minus M, okay. And if it is 1 0, so we add it, okay. So, that is we did. Now, one interesting thing, instead of looking into 2 bits, if we see only 3 bits, then we will get something different. Let us say we have the bit, that is, let us say we write ki ith bit position, I minus 1 bit position, and then we write ki I plus 1 bit position. Let us say this is 0, this is 1 and this is 0. So, now what we know, if you see this 2 bit position, what is that 0 1, that means it is, that is block of 1 is going to start. Okay. So, then what will we do? We just subtract the multiplicand, and next 1 0, that means this position is finished, then what we do? We will subtract it. So, that is we do it. But interesting thing is that if you see any value, say let us say 0 1 1 0, if this is the multiplier, then what we do it? This is 0. So, 0 0, what we do it? 0 0 means no operation, then 0 1, block of 1 is going to start. So, then what we do? At this position we put minus 1, 1 1, again no 0 in this position, and 1 0, that means 1 is finished. So, we do plus 1. But what is this minus 1 0 plus 1 is what? Say, as we know, see suppose if you have a value 1 0, if you do shift on the left side, so then it will come 1 will come here, 0 will come here, and then 0 will be here. So, simply if we shift 1 bit, it is nothing but the multiplied by 2. So, this is, even though if you shift 1 more bit, so then 1 0 0. Okay. So, this is 4, 4 into 2 8. So, whenever we are moving on the left side, we are shifting on the left side. So, there is a multiplication with 2. So, therefore, what is that if we consider this bit position right. So, when we do the -1, so it is nothing but with respect to this position is actually we are multiplying with 2 at this bit position. So, it is nothing but minus 2 m. Now, if you combine these two, this position it is 0 and this position it is -1 with 2. So, you will get this value is minus 2 obviously with multiply m. Similarly, if you combine these two bit position, so that is called bit pair. If you take the bit pair, so this is 0 and this position is 2 m plus 0. So, this is coming 2. So, instead of doing for each bit position, what we can do? We can make them pair. This is one pair, this is one pair, and we do perform one operation. So, therefore, the number of partial product will be reduced by half. Okay. So, basic idea that if you have a value 1 0 1 1 0 1 0 1 something like that. So, this is position I, this is I plus 1, I position 1 means it is just this position is if you get multiply with 2, you will get this weight 2 something like that. Okay. So, now what you do it? This is something called bit pair recording of the multiplier. So, first what we do it? We have the multiplier bit, we convert to corresponding Booth's recording, and from Booth's recording to we will do the bit pair recording, and then we will do perform the actual multiplication operation using Booth's algorithm. Okay. Maybe with one example, if you have still you have doubt, then everything will be clear. Okay. Here we go. Let us say in the last example, so we perform is 13 plus 13 into minus 6. Okay. So, we perform the operation plus 13 into minus 6. So, plus 13 means what? Plus 13 is 0 1 1 0 1, and then what is minus 6? Minus 6 is 1 1 0 1 0. So, this is plus 13 and this is minus 6. Okay. Now, what you do it? We did in the last class. If you see here, so we perform here operation, the result is 111 0 11 000 1. Okay. We should remember this part. Okay. So, now what we do it? So, this is the multiplier bit. Okay. So, what is the first step? First step you convert the multiplier to corresponding Booth's recording. So, first step is convert the multiplier bit to corresponding Booth's recording. Yeah. Second step, Booth's recording to bit pair recording. So, multiplier bit is 1 1 0 1 0. Okay. So, we assume there is a 0. So, then 0 0 means no operation, that is 0. 0 1, what is 0 1? That is 1 is going to start. So, therefore, this is minus 1, 1 0, 1 0 means 1 is already over. So, this will be plus 1, 0 1 means again 1 is going to start. So, it will be minus 1 and then 1 1, this will be 0. So, this is something called Booth's recording. Then we have to bit pair recording. So, you have to pair them. So, this is one pair from the right side. Okay. So, this is another pair and there is no pair. So, you also have to consider this one is another one. Now, what you do it? We know with context this one, when we consider the ith bit. So, this position is nothing but it multiplied by 2. So, therefore, is minus 2 is nothing but is minus 2 m, and this position is whatever the value. So, that is 0. Okay. So, this is 0 into m. M is multiplicand. So, this is m and this is twice m. So, therefore, what you will get it? So, this is 2. So, therefore, what we write it here? This will we write 2. Now, come to the next point. So, this is plus 1. So, this is again you consider this with respect to this bit position. So, that will be m. So, this will be minus 2 m. So, therefore, minus 2 m plus m. So, this is minus m. So, this is minus 1. Now, this is 0. So, this will be 0. Okay. So, now we forget this part, this is done. So, only we will do this operation. So, what is that? Multiplicand is 0, 1, 1, 0, 1. Then ideally we should write the Booth recording. Instead of Booth recording, what we write it? We will do here, this is minus 2 and this position it will be minus 1 and this position it will be 0, because we pair the 2 we paired, right. This is the third position and then this is the fifth position. Okay. Now, we will multiply it here. Now, as I said earlier, A equal to A minus m is nothing but the 2's complement, A plus 2's complement of m, that is I said. So, this is minus 1 as I said here, that is 2's complement. Minus 2 is nothing but multiplied with 2. Okay. So, therefore, what we have to do? First we have to find the 2's complement of multiplicand. So, multiplicand is this one. So, what will be the 2's complement in 5 digit? Okay. So, 5 bits. So, sorry. So, 2's complement of that. So, it will be 2's complement of m. So, this is obviously multiplicand. So, what will be the 2's complement? So, sin bit will be 1, then it will be 0, 0, 1, 0, it will be 1, 1, right, 1, 0, 0, 1, 1. So, this is 2's complement. Now, multiplied with 2, that means simply put 0 here. So, that will be twice, this is equivalent to twice m, but 2's complement. Now, what is the first task? First task is you multiply it with twice m, but this is negative twice m. So, therefore, whatever the 2's complement, you have to shift one left side. So, it will be 0, otherwise it is not 0, right, 1, 0, 0, 1, 0, 1, 1, 1. So, now 2's complement, if you 2m is nothing but you have to put 0, and then how many bits? In last class we talk about 1, 0, 2, 3, 4, 5 bits. So, 5 bits means your results will be maximum of 10 bits, and this is a negative number, because you are multiplying with 2's complement and this is 2 means a negative number. So, therefore, your number will be start 0 first, then 1, then 1, then 0, then 0, then 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, because all are negative number, you multiply with minus 2, done. Next is minus 1. So, but it is the bit position we have to maintain from here. So, you have to leave this 2 bit position here. you have to start from this position here. So, what is that? Minus 1, again you have to do subtract. Subtract means, and minus 1 means actually minus m is nothing but 2's complement. So, 2's complement is this value. So, you start writing from here, that is 1 1 0 0 1 1 0 0 1 1 1 0 0 1 1, and then you write 0, sorry, not 0, it is a negative. So, it should be 1 1 1. Next you do the 0. So, 0 means 0, okay, and you have to start from which position? So, 0 should start from the 5th position. So, 1 2 3 4 5th. So, this is 0, 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 this is 0. Now, you add it. So, earlier you had 5 partial product, now it is reduced to 3. Okay. So, it is okay. So, you add it 0 1 1 1 0 1 1 0 1 1 1 1 0 1 1 1 1 1 1 1 1 1. So, what was the results? 3 1 0 0 0 3 1 0 1 1 0 0 1 0. So, 3 1 0 3 1 0 3 1 0, then 1 1 0 0 1 0 1 1 0 0 1 0. So, let us perform another operation. Let us say last day we did not do minus 7 into minus 3. So, let us do it minus 7 into minus 3. So, minus 7 is nothing but 1 0 0 1. Okay. So, and 3 is 1 1 0 1. So, 3 is 0 0 1 1. So, you take 2's complement 1 1 0 1. Oh, that is right. So, 1 0 0 1 is minus 7 is 0 1 1 1. So, 1 0 0 1. Okay. So, that is also okay. So, now what we have to do? This is multiplicand. So, multiplicand, this is 2's complement of the multiplicand. So, this is multiplicand and this is multiplier. So, what is the first task? You have to convert the multiplier bit into corresponding Booth's recording. Okay. So, then it is 1 1 0 1. Okay. You have to assume 0 here. So, then 0 1, that means 1 is going to start, obviously this should be subtracted. Now, 1 0, 1 is completed. So, then it should be addition. 0 1 again is going to block of 1 is going to start. So, there should be minus 1 1 1, it should be 0. Now, you put a pair here, this is one pair, this is one pair. So, then what will happen? Plus 1 minus 1. So, here with respect to this one it should be 2 m. So, we have 2 m and then minus m. So, then we have only plus m. So, here we have plus 1 and here we have minus m and then 0. So, we have minus m. So, therefore, you have minus 1 here. Okay. So, now we remember only here. So, what we do it? Now, we perform the multiplication. Okay. So, what do you do it? So, we have the number is 1 0 0 1 and then this bit position we have to addition and we have subtraction here. So, addition means here 1 0 0 1. Okay. So, therefore, we write 1, this will be 0, this will be 0, this will be 1 and because sign bit is 1. So, it will be repeated. Okay. So, therefore, 1 2 3 4 5 6 7 8. Okay. Next, you leave these two position. Now, start from here to minus 1. Minus 1 means you have to take 2's complement of this one. 2's complement of this one is nothing but 0 1 1 and then number is what? 0. So, therefore, here what you have to do? So you have to take 1's complement. So, 1's complement means you have to take 1 1 1 and then what you have to take 0 0 0 0. Okay. So, now we have to add here. So, now you add 1 0 1 1 1 0 1 1 1 1 1 0 1 1 0 1 1 0. So, what do you get it? So, this one would be minus 21, sorry, plus 21. So, what is this value? This is a positive number, no doubt. 0 1 2 3 4, 4 means 16, 0 1 2 means 4, this is 1. So, this is giving you 21. So, what is the observation here you should make the observation is like that. So, here earlier if you go you would have how many terms? 4 partial product, here drastically reduced to 2 partial product. So, this is the advantage. Okay. So, now is as I first day we say we should explain why does Booth's algorithm let us take one simple example here. M into say value we take is 0 0 positive number. First we talk about positive number 0. What is this? 0 1 2 3 4. So, this is nothing but here what we can write it 0 1 2 3 4, we can write 2 to the power 4 plus 2 to the power 3 plus 2 to the power 2 plus 2 to the power 1. Interestingly, this is what 30, we are multiplying with multiplicand. This is we can write m into 2 to the power 5 minus 2 to the power 1. This is nothing but m into 30. See what we do it, this bit position we are subtracting. So, that is subtraction, and in between we are not doing any operation because all are 1 1 1 1 1 1, again we are adding here at this position, right. When we will get 0 1, so we are adding at this position. So, this is nothing but we subtracted here and then we added it here. So, that is we are doing and that is why it is working. So, one more example, here we have the block of 1s. Okay. So, it can be something like that. One more example we can take m into let us say 0 1 1 1 1 0 1 0. Okay. So, this can be written as m is okay 0 1 2 3 4 5 6. Whenever we see is a block of 1, block of 1s, this one we can write something like that. Okay. Okay. Here we can write 0 1 2 3 4 5 6, this is we can write 2 to the power 7 minus 0 1 2 3, 2 to the power 3 for this block of 1. Now, this is also a block of 1, this is we can write here 0 1. So, 2 to the power 1 minus 0 1, okay. 2 to the power 1 minus 2 to the power 0, sorry 0 1, okay. 0 1. So, we should write 2 to the power 2 minus 2 to the power 1. So, here whatever you see 0, 1, 2, 3, 4, 5, 6. So, you write in the next position, that is 2 to the power 7, and then for here you subtract it 2 to the power 3. So, as you have seen that this is a small number. So, this is we can write 0, 1, 2, 3, 4, that can be written as 2 to the power 5 means starting, ending plus 1 minus starting. So, this is same as similarly what we are doing. So, whenever we see 0, 0 no operation, 0, 1, so we will subtract. So, that is subtraction is there, and then 1, 0, then we have addition, then we have the addition here. Now, again 0, 1, whenever you see 0, 1 means subtraction, that is we did in subtraction, and every time we are shifting. Shifting is nothing but the multiplied with 2. So, that is the here power, and then no operation, no operation, no operation, and here when we see this position, then we add it. This position is nothing but 0, 1, 2, 3, 4, 5, 6, 7. So, 2 to the power 7. So, that is why it is working. So, this is with positive number.